Hello everybody. So today we're going to be talking about nozzles and diffusers. And nozzles and diffusers sort of go hand in hand. Basically, a nozzle, I'm just going to draw it like this, right? And in all honesty, even when I do draw it like this, right? This is sort of just like a 3D point of view. Even when I do draw it like this, we don't know if it's a nozzle or a diffuser yet. What tells us if it's a nozzle or a diffuser? The direction of my arrows. So this just denotes that it's a nozzle, like it's going through here, going out there and everything. And there are a few key things that you need to know when we're dealing with nozzles, right? With a nozzle, nozzles, unless stated otherwise, are adiabatic. And this just means that the Q dot is going to be equal to 0. There's also generally no work done when we're dealing with a nozzle. So W dot is going to be equal to 0. Potential energy is also negligible. So the change in potential energy is negligible. And what we get with this, we can use the energy balance equation to be able to understand what's going on and what we need to do with this. I'm going to erase this nozzles up here so I can have space for the energy equation. And taking these into account, we're going to be able to cancel some things out and we're going to see what our end result is. And what I want you to be comfortable doing before you start skipping steps is writing out the whole energy equation, crossing things out, and then seeing what you have left. And it takes a little bit more time, but you should get the right answer every time if you do it properly. So we have our Q dot in plus W dot in plus our M dot theta, right? Which is equal to, instead of in, I'm just gonna write 1, right? So H1 plus V1 squared over 2 plus GZ1 is equal to Q dot out plus W dot out plus M dot H2 plus V2 over 2 plus GZ2, right? And I've said Q dot is 0, W dot is 0, delta PE is 0, right? So I can cancel that out. That goes to 0. That goes to 0. This goes to 0, right? This goes to 0, this goes to 0. And this goes to 0. So once I cancel all of that out, I'm left with an equation that ends up looking like this. Right? And this is sort of the general equation you're going to get with nozzles and diffusers. But there's one more thing we can do. We can cancel this M dot out. And why is that? Because we're dealing with steady state, right? So these numbers are going to be the same regardless of what they are, and we're able to cancel them out. So we end up getting an equation that looks like this. And this is generally what we can get with a nozzle equation, right? Or a diffuser equation. And they might ask you something like, what was the outlet velocity or something, right? And you're able to tell them that. You just solve for V2 if they ask you for the outlet velocity. Now, it's important to note that here are some things you're gonna get. So this is basically the same thing for a nozzle and a diffuser, right? This is the equation that you're gonna end up getting, but there's some key things to note with nozzles and diffusers that you can use these to double check yourself, right? So with a nozzle, your P1 and P2 are going to be different. Your V1 and V2 are going to be different. With a diffuser, it's going to be the same thing. And with a nozzle, your inlet pressure is actually going to be higher than your outlet pressure. A nozzle produces velocity at the cost of pressure, right? So your P2 is always going to be lower than P1. So you're going to get something that looks like that, and it's going to be the opposite for a diffuser. The outlet pressure is going to be greater than the inlet pressure. And I mean, it's sort of hard to wrap your mind around it, but basically the kinetic energy is being converted, the pressure is being converted into kinetic energy, right? So V2 is going to be much greater than V1, and it's going to be the opposite for a diffuser. So these are just some key things that you need to remember with nozzles and diffusers. We're going to go over some example problems and everything, but I hope I was able to break these down for you adequately and everything. Please don't forget to like and subscribe. Leave comments in the comment section if you don't understand anything. Maybe I can help there too. And let's keep on learning thermal.